Hello. In this video, I'll be analyzing the circuit using Kirchhoff's law. Kirchhoff's law is a method of circuit analysis based on two principles: Kirchhoff's voltage law and the Kirchhoff's current law. So in order to use the Kirchhoff's law, the first thing you want to do is that you want to label your circuit's current by branch. So this branch, you want to label the current passing through it. This branch, you also want to label the current passing through it. So let's call the current passing through this branch I1 and the current passing through this branch I2. Okay, then the next thing we do is that we label the polarity of the voltage drops. So we expect a voltage drop to be across this resistor and another voltage drop to be across this resistor. So as you have seen in as I have mentioned in one of my earlier videos, the polarity of this voltage drop would be on this side we have positive, because this terminal of the resistor is closer to the positive terminal, so it is positive. That would make the other terminal negative. This terminal will be negative and this terminal will be positive. Now that we've assigned the polarity of the voltage drops, we can now write our KVL and our KCL. Now, let's start with the KCL. The Kirchhoff's current law states that at any given node, the sum of the currents entering and leaving the node is equal to 0. So let's take this node for example. You see current I1 is entering the node, so that is positive, and current I2 is leaving the node, that is negative, and we expect them to be equals to 0. For that reason, we can say that I1 is equals to I2. After that, we can write the Kirchhoff's voltage law for this circuit. Now to write the Kirchhoff's voltage law for the circuit, you pick a node to start from. Say we start from here, then you move along the branch, you hit this resistor first, then you look at the polarity, and the polarity is positive, so you write the KVL as the current positive, which is the polarity that you hit first, then the current I1, then the resistor 2, that's the voltage drop across the resistor. Then you proceed and hit the second resistor, which is another positive I2, then 3. Then we proceed and we hit the negative terminal of the battery. So for that reason, you get minus 20 equals 0. Then this infers that 20 is equals to 2I1 plus 3I2. Recall that from this step, we have already determined that I1 is equals to I2. Recall. Okay, so we can therefore say that 20 is equals to 2I1 plus 3I1. This implies that 20 is equals to 5I1. This would imply that I1 is equals to 4 amperes, right? Then we can calculate the voltage drops across each resistor. So across resistor 2 ohms, the voltage drop would be, say, V1 equals to 2I1, which is equals to 2 times 4, which is 8 volts. Then V2 would be equals to 3I2, which is equals to 3I1, which is equals to 3 times 4 plus 2, 12 volts. And that is how we find the currents and voltage drops in the circuit. Thank you for watching.